Right, question 14. We've got a uniform cross-section here, A, B, C, D, of a solid block. There's a parallelogram with DC equals 10.6 and the perpendicular distance between the parallel sides EF is 8.2, shown below. The length of the block is 15.7. Okay, so it says calculate the volume of the block. Calculate the volume of the block. We have to do it twice. Now, don't forget here it's talking about uniform cross-section of a solid block is parallelogram. So when they talk about cross-section, remember in page 2 of the formula booklet, they've got this here, a prism, okay? So when they're talking about cross-section, they're telling us that this shape is a prism. In other words, once you've got your cross-section, it's the same all the way through. In this case, it's a parallelogram all the way through, okay? So it's a block of this shape for a certain length. So the first thing you need to do is work out the area of this cross-section, okay? It's the area of a parallelogram. And it's really easy because it's like a rectangle really, isn't it? It's like a rectangle that's been pushed over. So like length times width, of course we call it base times height, okay? So the base is 10.6 and the perpendicular height is 8.2, okay? So I'll work that out on my calculator. 10.6 times 8.2, and I press the ST and it comes out 86.92 centimeters squared. Alright, now I've got the area of this cross section, okay, and it's a bit like, as I said, going back to this, it's a bit like this, isn't it? You've got the area of the cross section. To get the volume of the prism, to get the volume of the overall shape, the prism here, you just times the cross section, the area of it, by the length. Now we know the area of this is 86.92, so to get the volume, you times the 86.92 by the length of it, which is 15.7. Okay? So again, you calculate that 86.92 times 15.7, and that comes out to be this number here. Okay, so 1364 point, and I'll go for 1 decimal place. Okay, simply because the measurements are given here 1 decimal place. So I got 1364.6 centimeter cubed. Okay. Now part B, it says the block has a mass of 10.5 kilograms. Calculate the density in grams per centimeter cubed. Okay, so we're talking about this block up here. We know its volume. Now, of course, its mass, we've got there, block has a mass of 10.5 kilograms. They want the density. Now, remember with the density formula, use the density, mass, volume triangle. Okay, and if you want density, which is what we want here, we've got to divide the mass by the volume. Okay, divide the mass by the volume. Of course, there's a bit of a clue here, isn't there, with the units? Because if you look here, you've got grams per, right, which is divide. Grams divide by centimeter cubed. In other words, the mass divide by the volume. So you'd actually get given the formula there. But remember the triangle because it does help. Mass over volume. Now, if we look at the mass, it's 10.5 kilograms, but we want it in grams. So of course, kilo is 1,000. So it'll be a kilogram is 1,000 grams. So you've got to do 10.5 times 1,000. Okay, that comes to be 10,500. That's in grams, right? So when it comes to working with the density, then it's mass over volume, as we discussed. The mass is 10,500. The volume we worked out here. Okay, 1364.6. So you divide them together. So we've got that there. So I'll use that as my answer. Divide by then 1364.6, and it comes out as 7.69, so maybe 7.7 grams per centimeter cubed, and rounds to 1 decimal place.